Good morning, ladies and gentlemen, members of the press. My name's Hugh and this is Matt, and today we're going to be telling you about our cutting-edge new technology, the Mosquito Clamp. Aptly named due to the clamp-like appearance that the early generations have taken, the Mosquito Clamp utilises a brand new air design that separates it from other mechanical traps that are on the market. This forced air technology, or FAT, works by increasing the effectiveness of the trap, and the capture volume is also significantly increased for that reason. Today I will be presenting the project introduction and scope, along with some of the product markets that we've identified, and Matt will be going through the preliminary concept design. Mosquitoes and biting midges are a worldwide problem which the development of the Mosquito Clamp hopes to assist. Female mosquitoes require a blood meal from a host in order to get the protein required for them to reproduce. The Mosquito Clamp will work by subverting the female hunting techniques so that the female mosquito actually sees the trap as a host, and when it flies in to get that blood meal, will be caught. This works quite well because lowering the female population will in turn lower the local population of the mosquitoes, as the mosquito average lifespan is around 14 days. We've prepared this problem scope for the media conference to give an idea of the issues that the Mosquito Clamp team hopes to deal with. Firstly, the team will design a trap that will capture and also attract all the host-seeking mosquitoes from a surrounding area. With the lowering of mosquitoes comes a lowering of mosquito-spread diseases such as malaria and dengue fever, and this is a very important effect that we hope to utilise in third world countries, where medicine and that sort of thing is not quite as, more scarce. We've also identified a lot of potential in the tourism and hospitality business, as severe mosquito colonies can literally drive customers away from a place of business. Male mosquitoes and younger mosquitoes, as well as larvae, will not be directly affected by the trap, as this effect will come in time as the lowering of the female mosquitoes occurs. The requirements of the average user of the Mosquito Clamp are fairly straightforward. Probably the most important factor of the Mosquito Clamp is that it captures 100% of all of the insects that it attracts. This is for the reason that if the Mosquito Clamp doesn't actually capture 100% of those biting insects, then it has the effect of just luring all these insects to the clamp's location and not actually having any further effect. And this is very undesirable. Along with this, there will also be a very long life expectancy for the clamp. It won't break down too easily. It'll be simple to maintain and power efficient, and compact and visually appealing. It's also important that the Mosquito Clamp is designed for many different environments. And for this reason it will be customisable to cater for the vast series of mosquitoes and biting midges in different environments. Market research has also indicated that users would like the ability for the traps to be made portable to allow for safe storage. In cafes, sporting clubs, tourist holiday parks, schools, and directly to homeowners. And now I'll hand over to Matt, and he'll run you through the preliminary design of the product.
Good morning everyone. Basically, due to our confidentiality restrictions on this project, we can't show you our full design, but I can explain to you how and why the Mosquito Clamp will work. Basically, by using chemical and physical lures, we're going to attract mosquitoes into a capture area within the trap, where they'll then be sucked up into it. Our airflow system is a revolutionary 5-tube design that promises to dramatically increase this capture area on each trap. These tubes are designed to minimise air resistance, and they're all aligned for optimal flow. Each tube will contain an electric fan which will draw this air into the tube and up into the trap. Mosquitoes and biting midges that are captured in each trap will be eliminated by directing them through a series of electrified mesh into an easily cleanable net. We're going to do a demonstration for you today with the electric mesh, with this tinsel acting as a mosquito. So it just gets that quickly. And the mesh only runs at 0.5 milliamps of current, which has no lasting effect on humans. And Hugh's going to help demonstrate this here now. That's actually 1/20th of the national standard for electric shocks, like that. mosquito clamp units will run off mains power with the ability to modify them to a battery source. And the major lure we're going to use is going to be carbon dioxide, which will be fed through a stack on the top of each trap. This carbon dioxide is sensed by the female mosquitoes because it acts as like an animal breathing, and then they'll go and hunt it. The major lure of CO2s are used along with light, heat, and biochemical lures as long as infrared. And when the mosquitoes get close, they actually go in to land on the trap as if it was an animal. One of the major advantages of the mosquito clamps that can be used, as shown in this video, in barrier design. Mosquitoes come out of the lakes and trees seeking that blood meal, and as they get closer, they sense the carbon dioxide from each trap. They go in for the chemical lures and get quickly eliminated before ever reaching the humans in the house. Basically, our trap provides an effective lure and capture system for mosquitoes from the surrounding area. The design utilises carbon dioxide and a range of lures into attracting mosquitoes into an airstream where they are then trapped and eliminated. Our mosquito clamp is ideal for use in the hospitality industry, with schools, sporting clubs, local councils, and we plan to develop it with 8 organisations for the future where we can help eliminate mosquito-borne diseases such as malaria and dengue fever. Our current progress will realise a working prototype by the 4th quarter of this year, with manufacture beginning in mid-2011. We actually have these information sheets available for those of you who are interested, and if we'd like to take any questions now.
Can I just ask, do you think it'll provide an effective solution to the mosquito problem, that causes malaria and dengue fever, like you said before, and how could they be installed on a grand scale?
Basically, by eliminating female mosquitoes, who are actually the carriers of the disease, it basically eliminates the disease itself. In North Queensland, back after World War II, the Army sprayed every mosquito that was in existence, and that's how we wiped out malaria in Australia. Basically, by using these units, which we aim to cost under $100, you can supply them to third world countries and set them up around a community or village, and just protect that whole village from the mosquitoes.
I was just wondering the estimated range for each mosquito clamp.
Current range we're looking at with flow tests we've done is up to about 50 metres approximately, which is it's that average with the current market ones.
The carbon dioxide, about 30 metres is the range on that, with up to 50 metres depending on wind flow, and the chemical lures about 15 metres.
Now, the clamps kill mosquitoes. Will they have any other effect on other insects that may be vital, for the environment?
Basically, only things that are attracted to this are the insects that hunt blood, really, because they're looking for carbon dioxide to attack an animal. So if the insect doesn't look for carbon dioxide, it won't even go near the trap.
If it's in a location where there's a large group of people, what will make the insects more likely to go toward the trap rather than the actual human beings?
The idea is with the barrier system there, you don't want to have a trap in the middle of people because it will just bite the people. You need to effectively separate the source from the people so they will go to the trap. If you're standing next to a lake, really there's nothing you can do about it.
In what ways do you think the clamp's going to be superior to other repellents, such as Aerogun and that kind of thing on the market already?
Repellents will keep the mosquitoes away. It doesn't actually eliminate the problem. As soon as you take the repellent off, they'll come back and bite you. You actually eliminate the mosquito, they're gone. You can't do, they can't just respawn.
Is there any safety issues with having just carbon dioxide, or if you had a bunch of kids playing in front of the bed? I mean, would that be?
Well, carbon dioxide, we've actually 600 millilitres per minute is the rate we let it out at. This is equivalent to human breath.
Success rate of women 100% because all the males are still in, is that right?
Males don't bite the humans.
Oh, okay.
Well, effectively, yes, the mosquitoes will still be around.
And so that's how you calculate the success rate because...
Success rate is calculated on how many mosquitoes we find in the trap at the end of the day, and then over time, after you eliminate all the females, they can't reproduce. The life cycle is only 14 days.
Do you need someone to clean it or...?
Yes, but other designs who don't use an electric mesh actually just have a trapping bag, which needs to be cleaned like every 3 or 4 days. With us eliminating mosquitoes, we can have a bigger bag, which may require maintenance only. We're assuming about 2 weeks now.
And it's safe for anyone to be around that? Or do you need someone special to come in?
It's just the tube breaks in 2 pieces, and it's just a net. Unscrew the net, and you can just toss it out.
Just like a vacuum cleaner.
Yeah, pretty much. You want one more?
No, that's it, thank you.
That's it.